Alright, it's time to start our lovely trig unit here. So we're going to go over some right triangle trig ratios to start off today. Whew, exciting stuff. Alright, some of this might be a review for you, but just some important definitions here. We got our hypotenuse, which is the side that is across from our right angle, yes? Alrighty. Now theta, if that's our angle we're talking about, this will be our opposite side, and this will be our adjacent side. Okay, so our opposite and our adjacent. Now, let's draw this triangle once more with the right angle there, but let's put theta here. This is still my hypotenuse, but now this is my opposite and this is my adjacent side. Okay, so the opposite and the adjacent, they change based on which angle we're talking about. Okay, so we're going to be talking about one of the two angles that are not the right angle. And then the opposite and adjacent will change based off of that. So definitely want to write what we have here down. Okay, so we have sine is our opposite over the hypotenuse, or so. Our cosine is our adjacent over our hypotenuse, abbreviated as ka. And tangent is our opposite over adjacent, toa. So we have so, ka, toa. It's a lovely little acronym, if you will, to remember these trig ratios. Now, if you raise your hand one day, maybe on the day of the test or a quiz, and you say, hey, how do I spell SOHCAHTOA? You will not be told, as the whole point is to remember how to spell it so you can get the ratios, all right? So those three parts, the making SOHCAHTOA, will help you remember what the ratios are. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Alrighty. So let's practice with that, shall we? We're going to involve our special right triangle. So if you remember, our special right triangles, if it's a 45, 45, 90, it's 1, 1, and root 2. And then if it's a 30, 60, 90, 30, 60, 90, it's 1, root 3, and 2. Okay? So we'll use those as our reference. Now, for sine of 60, if it's sine of 60, we're looking at this angle up here, and sine is opposite over hypotenuse. I'm just going to jot down so to remember, all right? And this guy's ka, and this one's toa. Okay, all righty, so for sine, I'm looking at my opposite, which would be root 3, over my hypotenuse, which would be 2. And it's because we're looking at it from the 60, so the opposite is root 3. Okay? And the hypotenuse is across my right angle, which is 2. All right. So there's my answer. Next one. Let's go with cosine of 60. Well, cosine is adjacent over hypotenuse, so I'm looking at the 1 over 2. So 1/2 for this one, right? My adjacent side with respect to the 60-degree angle, the adjacent is this guy, my hypotenuse is that guy. Awesome. And lastly, we have our tangent, which is of 45, which is opposite over adjacent. So really, from either one of these angles, it does not matter because they're both 45. My opposite is 1, my adjacent is 1. So 1 over 1 or just 1. Okay? Awesome. Lovely. All right, so for this one, we got a few parts. We got to find BC, and then we're going to find the tangent of angle B and the cosine of angle A. All right, so first things first, we do need to finish out this triangle. We got to solve for the missing side, so I'm going to do it with Pythagorean theorem. 5 squared plus, so we'll say B squared is equal to 7 squared. Remember, the 7 is because it's my hypotenuse, it's my biggest side. So we've got 25 plus B squared is equal to 49. We're going to subtract that 25. We'll get B squared is equal to, what, 24. Square root it. I get B is equal to, if I break this down to 6 and 4, I'm going to have 2 root 6. Okay. So that is my BC, 2 root 6. Done with the first part. Okay. Next one. All right. Let's go with, let's see here. So if it's tangent, we've got toa, right? I'm going to jot that down so I remember. And after a while, you won't need to do that necessarily, but we'll do that for now. So my opposite of angle B is 5. And my adjacent of angle B is 2 root 6. Now, do you think we can leave it like this? Heck no. So what I need to do is I need to rationalize it by multiplying by root 6 over root 6, which gives me 5 root 6 over 12. And can I simplify that at all? No. Done. All right. 5 and 12, they don't simplify, so we'll leave it. Remember, you can't mess with what's in the radical, just what's on the outside, or if they're both on the inside. Okay? I can't get that radical to look better, so we're going to leave it. All right. Cosine of angle A. And for cosine of angle A, we're looking at my adjacent over my hypotenuse. So my adjacent of angle A in this case is 5. And then my hypotenuse is 7. So 5 over 7. Denzo! All right. Lovely. All right. Find the sine of angle N if the tangent of angle N is 5 over 12. This is a different type of problem than what we've seen. We don't have a triangle right now, but we can make a triangle with these particular values. Okay. So if I draw a triangle, there we go. Let's call this angle N. There we go. My opposite of angle N, my tangent is opposite over adjacent. The opposite is 5. The adjacent is 12. And there's my right angle. Well, I want sine. Well, sine is opposite over hypotenuse. Well, I don't have my hypotenuse. Could I find it? If you know your triples, real easy. It's a 5, 12, 13 triangle. So what is my sine of angle N? I don't even need to write angle. We'll just say sine of N is equal to opposite over hypotenuse. Boom. There we go. So we had to create our triangle, find the missing side if necessary, and then finish out the problem. Voila. Alrighty. Now it's kind of like the reverse, if you will. 24 over 25 is the sine of what angle? Well, let's remember that opposite over hypotenuse for sine, right? So if my opposite side is 24 and my hypotenuse is 25, well, obviously the hypotenuse is 25 because it's across on the right angle. But which angle has 24 as its opposite side? Well, that's angle A, right? So this would be angle A. And then tangent is, 7 over 24 is tangent of what angle? Well, where the heck is the 7? Oh, wait, triples, 7, 24, 25. Tangent is opposite over adjacent, right? Toa, in case you forgot to write it down. I don't know why I wrote another C. There we go. Alrighty. So tangent is opposite over adjacent. Well, what's opposite, or what angle is opposite of 7? 7 is opposite of what angle? That is angle B. All right. Awesome. I was going to say lovely and awesome, and then it was all, yeah. Find BC if tangent of angle B is 8 over 15. So we're looking at it from angle B. Right? My opposite is 16. And 15 is my adjacent. That doesn't make sense because I only see a 16 here. What does that mean? Well, remember, ratios are going to be reduced, right? Well, 16 is double 8, right? 2 times 8 gives you 16. What's 2 times 15? Well, that would be 30. Ooh. Ain't that wonderful? Very nice. So BC in this case would be 30. Cool. So that's just a reduced ratio. Uno mas! What is the sine of angle A if the tangent of angle A is 7 over 24? Well, 7 over 24, we'll call this A. Here's my right angle. Opposite over adjacent, right? Tangent is opposite over adjacent. You got to know your SOHCAHTOA. Well, this is going to be 25 then, right? Because it's a 7, 24, 25. Hence why those triples are so important. Not having to do Pythagorean theorem every single time. So opposite over, there we go. Opposite over hypotenuse for sine, which would give me 7 over 25. Cool beans.